Morning, everybody. Welcome. Happy Monday, all that fun stuffs. Just rolling in, so let me know you're here in the chat and I'll add you to the attendance there. Ooh, homemade chocolate cookies. Very nice. I had the Farm Boy chocolate cookies, and they were not very good. In fact, I still have them. That's why they're not very good. Morning, Owen. Morning, Erica. Morning, Jared. Morning, Katrin. Benny, you ate your hopes and dreams. That is just something. Sorry, Owen, that probably is not an okay thing to say. All right. Morning, Yuli. Morning, Kendra. More Lucas, more Maddie. Look at the whole freaking crew so far. Kendra's here. Eric is here. Larissa, Benny, Owen. There's only like 5 kids here. Oh, Ben. Sadie's here. Morning, Sade. Kendra, Owen. Okay, so just looking through my attendance. Oh yeah, there I go. I got Ben, Sam, Teddy, and Crystal, maybe? Not yet. Kathleen, also I don't see. SJ, I'm pretty sure he told me he was going back today. I think. There's Teddy. Awesome. And what about Zion and Ruth? So Crystal, Kathleen, Zion, Ruth. If they're there, that would be lovely. Alrighty. So I've marked like a lot of your graphs that you made for me where you had to come up with an hypothesis and then like record your data, things like that. I have not marked everyone's because I asked for the EDSB post and you to reply to that EDSB post. That way you can tell me where your assignment is because I don't know whose group was with who. And I don't know exactly where they were located. So I just thought I'd get one central location for that. So if you haven't replied to that post yet, I didn't mark your thing yet. So if you could go to EDSB, reply to that post with where it is. You might have to scroll down a couple days now. It was just basically like a question that says, hey, where are you? Oh, hi, SJ. And Crystal's here. So just kind of on the hunt for Kathleen, Zion, and I think did I miss? Yeah, Sadie, that's fine. You're good. Yeah, if your partner did, that's okay. Because they used your name. They said like, yeah, blah and blah. That's fine. I just need to know where it is. And you can check in EDSB to see if I've marked it or not too, but I have. If you've responded to that post. Now I did have one group message me something different. I haven't gotten to that yet, so I think that was Lucas and Teddy. I have not got to your message yet, but other than that, everything should be good. Zion is now here. Awesome. Sup, dude. So just know Kathleen. Just know, and again, maybe it was Ruth that messaged. 1 second. I just have to look. I think Ruth sent me a message. Oh, yeah. She's flying back home. Okay. Okay, awesome. Thanks, Eddie. Perfect. Alrighty, so I believe that we are doing pretty good. I got one. Ellis, what's the best bubbly flavor in your opinion? Okay, awesome. I see SJ's responded to my poll and EDSB there. Thank you. Man, I have not tried many of those. I've just started like getting into like sparkling water. That sounds weird to say getting into sparkling water. You sound like a dork, but no, I haven't tried many of them. I don't know. What's your favorite flavor as you try to distract me here? So we did 7.3-7.4, and I kind of feel like you guys, let's just share this right now. I kind of feel like you guys were going to do these two examples here for me. That's what I think I asked you to do for homework. Maybe we'll take these up quickly. So if you guys could take these out, we'll just see that you guys get the right answers for these. So go to your... Isn't that what bubbly is? Isn't it just sparkling water, Ben? Could you go to your OneNotes? This is in 7.3, 7.4, and we'll go and start taking this up. Also, May 4, homies. Lightsabers up. Or chapsticks. That's what I got. Mr. DeGeller's got, supposedly he's got 4 lightsabers down there though, so I could go borrow one. Star Wars Day. All right. You're the first person. Yes. Okay, so I'm hoping everyone's got this out. We're going to take up these 2 questions. That is very disappointing. and we'll rock and roll. So this one says find the value of x. X is this little angle in here, and the length of DE. Given this side length is 7 centimeters. So you guys are always starting random questions here. We're remembering about all of these little pieces in here that we learned. And so we know that AB, it tells us in here, AB is 7 centimeters, sorry. That means that here is 7 centimeters, right? That length in there from A to B. I should draw little arrows. Sometimes that helps, right? And so then it says, I want to know what the value of DE is, or the length of DE. And so DE is the length from D to E, so from here to here, right? We want to know what DE is. And so this actually comes from, it's important that we know this because this isn't just some random line. This is the same line that if we go up here, you can see it's that kind of mid-segment line, right? Mid-segment, where we had, remember we did this before, where you took halfway down, made a point, halfway down through here, made a point, and connected them, right? And so that thing we learned was parallel, but we also learned that the mid-segment was half as long, right? So if we go down here, remember these little ticks here, when you get 2 ticks, that means that this thing here from, I know it's not very well described, but this thing from A to E should be the same length as from E to C. Like these little pieces, I wish I could put my fingers on it better than this dumb mouse here, but from here to here is the same length as from here to here, and that's what those dashes mean. Just like how this one has 1 dash, it's to show that this isn't the same length as this. But anyways, this 1 dash means this side length is the same length as this side length. We don't know what they are, we just know that they're the same. So I do know that this is the mid segment in here. It's that little mid segment. So if we know this is 7 centimeters, what is the length of DE then? Let's just see if you guys are paying attention. You're live this morning. Can you tell me what the length of DE would be? Awesome. There, people are alive. Thank you, thank you. Yes, 3.5. Thank you. Okay, so this DE is 3.5 centimeters, but I think probably we're going to write it on here because sometimes when you have those things like off the graph, I was going to say graph. You guys don't want to hear anything else about graphs. Here, is everyone typing 3.5? I'm going to type in 3.5 as well because I feel like that would be fun. Okay, there we go. So it's nice to like just keep throwing them, but just because we answer doesn't mean we're alive. Oh, sorry, Kendra. Just because we have it on the side, you know, maybe we need to solve for more things. So having that info on the picture is really helpful later on, just so you know everything where it goes. Okay, so we're getting there. At least on the inside, my goodness, you guys are ridiculous. What we also know about these lines is that they are parallel. And that's going to help us in a second here, because if those things are mid-segments, that also means they're parallel, which means that this angle x, like this line is a straight line, right? This line is a straight line here. So when this angle, or this line is parallel and it comes up and hits our line, if we make another parallel line, then these angles where it hits, because they're parallel, right, should be the same. If I'm looking at my ruler right now, hopefully this makes sense. I'll try and line this up. Why is it 58 degrees? Who made this friggin' triangle? Anyways, it doesn't matter. But you can see that I can get that same degree right here, right? And so it makes sense that, you know, if I put that ruler anywhere along there, because it's, you know, a parallel line to that thing, it's going to intersect it at the same angle, right? It should intersect at the same exact angle here. This angle in here, right here, right? This X should be the same as, you know, if I slide this over, this angle in here, right? And I'm sliding it over, which will be the same as this angle in here, because they're parallel, right? So that's kind of the trick that we're looking for here. So we need to know, I'll do it in green, what is this angle, okay? So remember, all of the sides in a triangle add up to 180. And then we're going to subtract the other two to figure out what's left, right? So we're going to go 180, subtract 80, subtract 35. So 180 minus 80 is just 100. Then you take away 35. You should be left with 65 degrees. Right, 65 degrees, perfect. And then that means this one here as well is 65 degrees. Can you guys make sure that you got that right in your homework? And if you didn't, maybe ask me a quick question either through a private Teams message or just open in the chat there. Either way is totally fine. I almost spilled my coffee on my computer. That was lovely. See that you understand that. Wait, hold up. What, Benny? Oh, sorry. I meant 180 minus 80 is 100, Benjamin. My bad. Because see here, it's, sorry. That's a really crappy 1. That's a really crappy 1. That's my problem, right? Is that all three angles in a triangle, this one, and this one should add up to 180, right? So what I'm doing is I'm doing 180, subtract this one, and that'll tell me what's left over. Sorry, it does look like a bracket, doesn't it? Yeah. It's a bit ugly. My bad. Sorry, I'll fix it. Boom. Now it just looks like a really thick 1. Or it still looks like a bracket. I don't know. Sam, what does that sentence even mean? When you say dance episodes, what do I mean? I know you mean, what do you mean? But that's the beauty of kids who short form you to one letter. They might accidentally make no sense in the end. Anyways, let's do the second one. So, if we're looking here, I'm going to erase what we had before. This was something that we kind of learned, but it wasn't part of our investigation. We just quickly looked back at the chart. And so remember, to find that little chart where there's a bunch more rules, you'd go to your textbook. And this would be on page, what was this, 7.3, I believe. So if I show you 7.3, we did kind of learn this, right? When we learned the, my computer is like not cooperating. There we go. Right, we kind of learned how if you take these kind of bisectors, these angled bisectors here, and go boom, boom, and you look in a square, you see that it's a 90-degree angle, right? And we also talked about how a rhombus does the same thing, but that's the only shape, right? All these other ones, I guess a kite, but who cares about a kite? Weirdest shape ever. But anyways, the square and the rhombus, more common shapes there for sure. They meet at 90 degrees. So that does tell me that these in here, and I think I helped you guys with this on the Friday as well, that these all in here are all 90 degrees because rhombus, right? All these side lengths, 1, 2, 3, 4, are all the same. They're all the same lengths, so it's a rhombus, so that will help us quite a bit. Alrighty, so if I know then that this is 90 here, right, and this is 32, I should be able to get Z. That would be where I would start, personally. I'd look for Z, and so to find Z, let me just get it with green here. I'm looking at, just so we're clear, I'm thinking about this triangle in here, right? So I know this is 90, this is 32. So to get this missing one, Z here, I'm going to go 180, minus 90, which will just be 90, right? Minus 32. So 90 minus 30 is 60. So it'll be 58, right? That little Z in there. Sorry, I should give it a little tick. Sometimes my Z's look like 2, so I cross through them. Z is equal to 58 in there. All right, so we've got a lot of angles. We just need to kind of figure out, you know, some of the missing ones. And that also comes from the whole parallel line idea here too. Knowing that these two lines are parallel and these two lines are parallel, it's going to help us think through some things that are going to be the same. Like when they're cut through like that, it'll be the same angle. And I don't remember how many of the angle rules you guys learned back in grade 8. So we're actually going to spend a day where we go through some of those angle rules. That'll be probably tomorrow, where we practice some angle laws. Just like a summary of them all, because today's lesson is like the last textbook one, but I feel like the textbook doesn't really give you a good summary of all the angle laws. And so angle rules, angle laws, same thing. By angle rules, I mean like the Z pattern for angles and things like that. I don't know if you guys remember talking about that, like parallel lines and, you know, when you've got a line intersecting them, the, you know, opposite angles kind of thing. Probably you've seen it before, some of you, but we'll just do some cool problems solving things with that. Angles rule. Okay, so we want to kind of get these angles up here, right? Which is pretty far away from kind of everything else we know. I'd love to be able to go in here and say, oh, this thing here, right? That'd be sweet if I could know what this was, but this isn't necessarily 90, right? I can't just like take this side, right? This angle here and be like, oh, that's like 90, so 90 minus 30. No, that definitely does not look 90, right? So it's not going to be like that. So what we're going to do is actually this big angle in here, that might be helpful if we could learn something over here maybe. So I'm going to start by solving angles as we go around our triangles here, right? So let's see if we can get, maybe instead we'll maybe get this side length over here, and that might be helpful to us as well. So let's try and maybe solve for this angle. So we know that this full thing here, that would be 180, right? If we had a full, like, starting all the way around. So in this case then, right, if I want to look for, let's call it like T in there. If we take that T would be 180 minus that 64 we have, minus 58. And Jared, you're saying that's also 64, like it's kind of like a symmetrical thing, or like I don't know what you mean by what the other angle. You mean this one? Like if I do that in my head, that's 120, 116. Oh no. Yeah, that's that one. Okay. For some reason that doesn't work in my brain. But I trust you. We all agree that that's 64. My brain says that can't be right. But I'm just an old man, so give me 1 sec. I need to confirm because we don't want to mess up going further. I trust you. I just, for some reason, like if you subtract those numbers, my brain doesn't like that right now. So I get 180 minus 64 minus 58 is 58. So this little T in here, so this guy is 58 degrees. Okay, that's actually really cool. Okay, I don't know what angle you were talking about, because that tells me that because we knew Z was 58, right? So if this is 58 and this is 58, that tells me, which is really cool, that we could learn, what is exactly across from this, thinking about our parallel lines, right? If this thing is just a square that's been flopped over, then that would tell me the thing that's across here, this would also be 58 and 58, which is really cool. Sorry, my nose hates me right now. Because if you look here, this triangle, right, in a rhombus, it's kind of neat. Like you've basically just like, because this is the same side length here and this is the same side length here, it's like a big equilateral triangle. And so if you're, I'm going to erase this here. Like if you just look at, sorry, not equilateral, my bad, isosceles. Like you know that this side length here is the same as this side length here, right? And so that's like a big triangle where the side lengths are all the same. And if you remember on those, sorry, not side lengths are all the same, but here it's because this tick and this tick, I should actually turn it the exact same way. Because this and this are the same, that means these angles would also have been the same. So that's another way you could have thought this one through. So we've got your 58, all that fun stuff in there. And 58, 58. So we learned this was 58. That means this one's 58. And so that helps us, right? So now we got y is 58. And then our final last one that I can't draw for some reason, x. That one's going to be pretty easy because we just know we got to do 180 minus 58 minus 90. And actually, we've already done that because it's the one that's left over, right? It'll be 32 as well. So that's just this one up here. Perfect. So yeah, you can kind of see that if you look at this a little bit better. I guess I was doing too much solving at the start. I wasn't actually looking at the equation or the question about how it's this triangle, right? And so because it's these side lengths are the same, then you should have this like good symmetry, right? Where if this is 32, then this side is 32. And if you solve this side for 58, then this side should be 58. So it should be pretty good through there. Cool, cool. Any questions about that one? Is there a step or an angle you want me to talk about again and how you get? I could probably do a little bit of a restart here to make our lives easier if I butchered that explanation in the middle a little bit. If not, we will motor. Let me just get this junk out of here. Get out. All right, no questions then it seems like. We're going to jump into this 7.5. Can you guys let me know if you don't have this? It's always easier to do that way. This whole one on 7.5, reasoning about polygons. Just kind of learning mostly about the idea of a centroid today, which I think is kind of cool, even though it sounds lame. Basically, a centroid is like if you take any shape. I'm trying to find like a weird triangular shape or other shape. Everything seems to be rectangular in my house here. But it's like, how do I find the center of something? So if I was to drill a hole through my shape, like any shape like this, how do I find the exact center where I choose to drill a hole through? So that way, if I like hung it from a string or something like that, it would lay perfectly level, like perfectly flat. It wouldn't like be tilted off to the side. And so actually in class, like if we were in class, I'd love to be able to take this with you guys and give you random shapes and have you guys try and figure out where the center is and then hang it by a string. It's really fun to see how flat you can get stuff. Now paper tends to just flop, so we have to use like that construction paper kind of thing so it doesn't just like... But anyways, that's what I would have loved. I hate when I have to do this, when I have to be like, oh, remember when you could have been in class and it would be slightly less painful? But anyways, we'll use our program there to figure things out as well. Well, we're talking about centroid. Centroid is like a nerdy name for just like the center of an object's mass, basically. Basically, like, it's typically thought of in volume because we're doing 2D shapes, but there should be as much of the shape on this side as on this side, and on this side as on this side, right? So basically, it's going to be like perfectly balanced. Mass means how heavy it is, right? So it's kind of like... Typically, yeah, a good way of talking about it, I guess I should have started with this. It's like your center of gravity. You always hear people talk about, oh, I've got a low center, or whatever. It's for three-dimensional peoples. But we're talking about our two-dimensional shapes here. We just want them to lay flat. Could be useful if you're making like a wind chime, something like that. So there's an example down below where they want to like hang different sized objects so that they hang kind of level when there's no wind, and then they bounce off each other when there's wind and make metal noises and things like that. So that's what we'll learn about. So I might just start off, if we don't look at your note for a second, just kind of want to talk about maybe some reasoning here. How do I open this sucker up? I want to take this over here. Any fun and exciting news on School Talk? Beautiful weather. Love it. Yeah, it was super nice. I think it was like, I don't know how hot it was where you guys were yesterday, but in St. Catharines it was stinking warm. It's like outside doing stuff. It's like, I was like 24 degrees, maybe something like that. It was amazing. Yeah, I got a bit of a sunburn on my neck too. Yeah, I can't remember the last time I had a sunburn, right? It would have been last summer, so pretty awesome. Pretty awesome. 21 there. So for like an hour. Very nice. Very nice. Yeah, we should all compare redness. Although that's a bit weird. Let's forget I said that. Pasty. Oh boy, the old Dutch farmer's tan, eh? Hey, what's that website called? GeoGebra. GeoGebra.org, and I want the geometry one. I'll link this in the chat. We want to, yeah, sure. I think you go start graphing, but then I actually don't want graphing. I want what's new. I don't care what's new. How about you just tell me what's old? Here we go. Geometry. Sorry. That was annoying. So, if you want, you could go here with me. It's not my website, Ben. I didn't invent GeoGebra. It's just the one where you go to. Anyways, let's just make like, to start, a triangle. We'll do the simplest shape. A weird looking one. Okay, so did you get brunt? What would you guys do? Can you use letters to explain to me, like from C or like between A and B or whatever? What would you do here to maybe figure out where the center of gravity of this triangle was? I can even mess with it a little bit so it makes it less obvious. So where other than, like, we're going to be able to look here, and let's pretend like, you know, you don't have GeoGebra, because you guys know that I can just go here and go center and click, and it tells me exactly where it is, right? So that's kind of cheating, because in real life, you don't just have a program where you look at the shape that you're trying to hang or whatever. Or you can think of like it's like in the kid's crib. You know in the baby's crib where they've got like the stars hanging and all the little shapes hanging in the baby's crib and they're all, anyways, like that. So let's pretend we're making something and we don't have GeoGebra. So what do you think? What would we maybe do to connect here? Owen says find the middle. Amen. Okay. So how do we find the middle? Lines. Lines. I wonder if you guys can see how you would get that. So maybe even just, yeah, from each point till they intersect. From each point to where? So where do I connect this point from? Midpoints intersection. Okay. So yeah, what you do, like, because look, we do have rulers in real life, so you can cheat a little bit. I know I can't just use the midpoint on whatever, but yeah, Jared would be right? So we're going to take the midpoint of each of these. So between C and B, right? So here and here. And I'd take the midpoint between C and A. And I'd take the midpoint between B and A. And remember, if you had a ruler, you'd measure this. It'd be like 4 centimeters long, and then you just go 2 centimeters up to get the midpoint. So you could do this, like we're cheating and using the midpoint button, and I know we could cheat to get right here. That's where we want to get, but anyways, we're going to get that in a second. So what would we do? You're going to connect your lines, right? Just like Jared and a lot of these guys said, it's hard to give you, it's hard, and I had a good little discussion a second ago with somebody saying, like, it's so hard to say what you're talking about over messages, or even vocalize it right now with shapes, because there's a lot of definitions and words that are annoying. Midsector, bisector, all this other stuff. So hopefully I'll teach you a couple of those today again. So yeah, we're going to connect this and this, this and this, and this, and the one across from it as well. Let's see. Is that point of intersection, if I use my little center button, I'm just going to click on the shape anywhere, right? Is it going to be exactly where those things intersect? Hey-o. Sweet. So that's how you could find the center of gravity. Gravity as a triangle is that we basically take these lines, right, and make it go right across to the other side. And you can actually see in your note here, those are called medians. So if you guys wanted to know the word medians, basically they're lines from each vertex of a triangle out. Okay, so let's just see here. I'm going to go and delete all of that. Let's make something a little bit easier. I'm going to go down to the regular polygon button, regular polygon, and I'm going to make a 4-sided square. I don't know why it doesn't just go on the screen. That's annoying. Okay, so I've got my 4-sided square. How would you find gravity? How would you find the center of this square here? Remember, there's words like diagonals. Is there any other kind of square? Well, no, there's not. There's just the square kind. There'd be lots of different ways, I guess, to find it here. I just wonder if anyone has an idea. Okay. Well, hey, Lucas says, draw a horizontal and vertical line from 2 different midpoints. Okay. All right, so sick. So where's my midpoint button? Where are you, you little jerk? Okay, cool. So yeah, just boom, 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 and connect the dots. Lucas wants to go across like this. Show wheat. And yeah, I don't even think we really need to do that to hit the mid-center thing. I think you guys would kind of believe that. Done, right? The other thing you can do with squares to save yourself a little time, right? Because sometimes, like, if you just had a square, it'd also be maybe even easier, right, to just take your diagonals like this, and that also would be our center of the square, right? It's just that way you don't have to, like, if this was real life and you didn't want to, like, measure out the length of the side and divide it by 2 and all that sort of nastiness, you could do that as well. Let's see if I can make a parallelogram, and let's see if we can come up with our idea here. So Control A, delete. Parallelogram. I believe I need to make parallel lines. So let's hit more, see what I can get here. Yeah, we're probably going to have to use we'll just make a segment first. Or 2 lines, we'll make 2 lines. And then I want to make a parallel line to this sucker here. What? Are you okay? I'm clearly not okay. Sorry guys, I don't know what's happening here. I want this to be parallel to that line. Okay, why was that so difficult? Okay, actually, yeah, Sam, you're right. We should use grid lines. That's a great idea. I like that. That'll just make it easier, I think. Show grids, major grid lines. Yeah, I like that. Thanks, Sam. That way, I think it'll be more clear. So we're gonna make it go from here to here. And then it'll be like, 4 across, and then there to there, and there to there. There's a parallelogram. Love it. Now I can turn off my grid lines, and we'll be good. All right, we've got a parallelogram. Love it. So, same slope, both sides, right? That's what we saw. This one was up 2 over 1, up 2 over 1, and this one is just slope of 0. It's flat. All right, thank you. I don't know why that was so difficult. Center of the parallelogram. Okay, center of the parallelogram. There would be a couple different ways of doing it. If we use Lucas's method again, it says draw a horizontal and vertical line from 2 different midpoints. Well, if we again were to take the midpoints, right, that would be totally fine. Through here, 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 and here. Let's see what that looks like, right, if we connect those with our little segment. Cool, let's see. Does that look like it's going to be in the middle? Well, I'm just going to click on the shape. Kendra says yes. Click it. Oops. Okay, clearly that was wrong. Midpoint or center of that. Okay, so I think I need to somehow select this shape. Join these things. I don't know what's going on with this. Sorry. It's because I have like too many different segments. Select objects. Okay. Construct. Yes. Oh, and 100%. We're gonna do the diagonals and confirm. I was just hoping. That I could like combine these things. That's really annoying that I can't turn it into a shape. Because it won't let me do the center. It won't let me like do it how we had it before. I guess I can make one on those points though. That's what I'll do. Okay. Control A, delete. Oh, you are annoying. Okay. Well, a regular polygon would make it so all sides are the same, and we don't want a regular polygon. We just want to use this. This will be better. I was doing midpoints. Oh. Sometimes life is good, and other times life is still good. All right, here we go. We got our polygon. Frig. All right, so mid segments. Did I miss? Tell me I missed. Please tell me I missed. Okay, you little jerk. This guy is not my friend to date. All right, so what I'm trying to show you, because some people already like made the connection here. If you go to these mid segments, is that now going to let me do the center shoving? Cool. So that worked, right? We found the center. The other thing that somebody suggested is, can't you just do the diagonals? Isn't that easier? Hey, look, the diagonals work too, right? So yes, the diagonals worked. Yes, our mid segments worked. It's perfect, right? Like, we're able to find multiple ways. Now let me change things up on you a little bit. So instead of this shape, let's delete that. Oops, not everything. Let's do a trapezoid, like behind the hockey net. Where is my polygon shape again? So I'm doing a trapezoid, right? There are parallel lines on the top and bottom, but the other lines are not parallel, meaning these lines are parallel here and here, but these lines are not. Okay, so let's see. The center, just so we're clear, the one that we're trying to get to is that right there. So we're going to look at a couple things, right? We're going to look at our midpoints and our diagonals and see if it works. So our segments, does it go through? Diagonals no longer work, right? We noticed that. So again, just so we can all confirm that what I did was accurate, I took my center, right? And I was doing the same thing we did before. I just click anywhere in the shape. It says there's the center. That's the center of gravity. But if you do your segments from the diagonals here, for this shape, it doesn't work. So it's like, darn. The diagonals was the easiest, right? When we did the square, when we did our parallelogram, the diagonals was the easiest. But here, diagonals doesn't work. So you need to be a little careful with the diagonals thing. Yes, it works on, we're going to learn today, squares, rhombuses, right? Remember, rhombuses is like a square that got punched. And it works on parallelograms, like all those shapes that have like parallel sides across from each other. But here, as soon as you have two sides that are not parallel, so like basically a polygon or a quadrilateral that's not really that common, right? In this case, or in society, most quadrilaterals in outdoor world are rectangles, squares, parallel, like they're all nice sided shapes, right? It's not just like randomly thrown together four sides of a parking lot. The parking lot is normally 90-degree corners, right? So how do we get that then? We do the old Lucas method that he came up with before, where you take the mid segments, possibly. Let's see if this works, right? Mid segments. So does connecting those work? Oh, that actually looks like it kind of missed, doesn't it? It should work. It does look like it kind of missed a little bit, though. You be gone. You hit. It's close, but it's not the exact same. I wonder if there's some rounding that happens in the mid segment thing here. You know what I mean? Like the program might round, like the height of this or the length of this thing might be like 2.3, and then it halves it, and so it's doing. Sam has that too. Yeah, it's supposed to work. Just so we're clear, I promise you, this is supposed to work. Imagine I just like didn't even like say anything. I'm like, and so that works, and I like quickly like. Anyways, I will admit this isn't looking right, but that's how you're. As I zoom in, you can see it gets worse, right? But it should work technically. I'm sure it's probably just some sort of like with the software it rounds as decimals. Make it slightly bigger. Yeah, how do you do that? Oh, that's smaller. I don't know. Whatever it is, we'll just, let's just pretend it should be massive. Settings. Just zoom out more. Yeah. See, guys, it's perfect. I told you it would work. It's bang on. Oh, man. All right, so let's just see. Let's just delete all that garbage. Take away these grid lines. It's killing me. Does this work if I just have like some random any four-sided shape? So that's pretty ugly, right? Do you even have the actual answer? Yes, Ben, the actual answer is you're supposed to do the mid segments. So you just leave me alone, Ben. So let's see. Will we get it for this one? This will be a weird one, right? This isn't a trapezoid. This isn't a parallelogram. This isn't anything. So I just want to see if I can get that there. Okay, so let's see. Again, diagonals. Not a chance, right? No way. Let's look at our mid segments though. So I'm going to go mid segment here. Mid segment. You little jerk. You little. Does. So fun. I got old man brain right now. I can't even click for some reason. Okay, click, and there's our center there. Hey, okay. Well, it looks to be, again, like my computer is spazzing. No. I would say no. Not going to happen. Because this software is not my friend today. But let's get the summary of the note going. Because at least that's regular. Anyways. You're supposed to be able to do any quadrilateral. Okay? It doesn't have to be a parallelogram or a trapezoid or any of those things. It should be any parallelogram or, any quadrilateral where you take those mid segments and just connect them. Yeah, my life feels like a lie right now. I think there's some weird rounding happening. I don't know. Or maybe the program's midpoint is not the centroid, like for gravity. I don't know. I don't know what it's doing. But it's clearly something is going on there. So it's GeoGebra. Let's just blame it on GeoGebra, and also it being 8:50 in the morning, so we don't really know. So, anyways, I apologize. They refine. Oh, maybe that's true, Sam. Like maybe they knock it over to a grid line, for instance. That'd be really dumb. But, anyways, it should work, and I apologize that was like so much effort to show you something that like rocks your faith in mathematics, but. Anyways, you'd get your triangle through these things called medians, okay? Basically, you take the median, the halfway point on each side, and you connect it with a point across, because there's not a side across. But when you have quadrilaterals, right, what you do is you look halfway on those opposite sides, and you connect them, and those are called, your little, your bimedians, okay? Medians. And your bimedians. Sorry, I think I was calling them mid-segments before, but mid-segments is when we made that little perfect parallelogram inside anything, right? Remember that? When you connect the mid-points of any any quadrilateral, and it creates a parallelogram inside, which we thought was pretty cool. Or maybe you didn't, but I did. And so, you call those the bimedians. So median cuts a triangle, bimedian does not. I can change the rounding. Oh, that's cool. Can I give up on GeoGebra? You guys are all like looking for solutions on me here. Oh, you guys are good. Settings. Right angle. Tool tips to 0 decimal places. Yeah, it's probably in there, eh? I don't know. press the gear. Oh, labeling, font size, rounding. Ooh, we actually probably want more digits, right? We want more digits. Okay, so let's do this again. Because you round to 0 decimal places, that means like if it's like 14.55555, it just rounds to 14. Like it just goes 0 decimal places. Let's see if that was our problem. Maybe some of you have already given up and you're just like, okay, we get the lesson, Mr. Ellis, just shut up and move on. But for those of you who want to see this work, I do this for you. Segment. Come on, baby. Be closer than last time. No, it's not any better. Okay. Well, I think maybe then we're at the SAM where this thing is snapping to grid lines. Let's just hope that's true. Looks like that's not true either. I don't know. Remind me to never use GeoGebra again for teaching something. I made this for you. That was pretty disappointing, wasn't it? I was really hoping that that was going to work out. Disappointing in general. Okay, so, yowza. The other thing that we just need, because there's a couple little things of reason in here, is that if you looked at any sort of trapezoid in general, it could be the weirdest trapezoid. So let me just show you here. My goodness, why is this the most annoying thing of all time? This. Let's go back to... Okay, I don't even want to do it. I don't want to do it. I can't select... just give me the mouse and delete. And anyways, well, what we could do is if we make any of those trapezoid thingies in here, right? So those parallel line is parallel to this line. And then who cares? We just go like, you know, there to there, there to there. Those are not same slope, whatever. If we were to look at the length, right? I'm going to measure the length of this side is 4. The length of this side. So this is why we had all those decimal places, because we didn't know what they're rounding, right? So here's 4 and here's 7. If I said, tell me what the mid segment was, okay? Boom. Boom. Sorry, I guess I should say our bimedian, because remember, median was from a point to the side across, and that was in triangles, but this is a bimedian. And we connect it here. The logic is, how do we know how long that line is? And this is some reasoning. That's why this lesson isn't just about centroids, it's about reasoning. Like, how do you find the center of a shape? How do you know how long this side is going to be? So it's all about like actual thinking and life skills. I guess it's good. So let's pretend, you know, you've got, oh, hello. For instance, here, you've got, and this I see is halfway in between, right? So this thing is 4. Oh my gosh. Anyways, that thing is 4. Let's see. Larissa is saying measure the length and divide by 2. Then at half the point, make a dot. It's 3/4 the size of the big one. Okay. So let's see. I'm going to delete this. Here, we might actually learn something. People going to be learned today. So I'm going to actually measure this for you here. This side length is 5.5. Okay. So calculator. Let's grab this sucker out. Sorry, my first suggestion was measure the length and divide by 2, then at the half line make a dot. Again, I I can't follow that. I don't know what I'm doing with that. Let's try the second one. It's 3/4 the size of the big one. Okay, so if we do 3/4 of, 3/4 is 0.75, right? It's 3/4, so 0.7, 75 cents, 3/4. So 75 cents of means multiply of 7. Okay, so you get 5 1/4, so it's close. All right, so somebody said take the 5 divided by 2. Yeah, I don't understand. Let me ask you this. It's basically halfway between the two, right? If you look here, from 4 to 7, if we looked at lengths being halfway between, if you add 1.5, you get to 5.5, and if you add 1.5, you get to 7. It's halfway between, right? So basically, how can I find the halfway point? Well, let me ask you this. If I said over here, if I was like, you know, you've got a 70 on your math tests and an 80 on your math tests, and I said, what's your average? All right, what's your average? Well, you guys would know it's 75. It's halfway in between. But do you remember the formula to get an average of something? Basically, what you do, especially as you get more things, right? You add up the number of things you have and divide it by the total number of things. So here, if I had a 70 on a test and an 80, I'd add those together and I'd divide by 2, and I'd get 70 plus 80 is 150. 150 divided by 2 is 75. Makes sense, right? If you guys wanted to know, like if you had another test in there, right? You added another number, then you divide it by 3, right? You have a 70, 80, and maybe a 50, right? Then you added 50 in and you divide that by 3. And so that's helping you get your average. That's kind of what EDSB is doing, although it does it more complicated because things are weighted differently. But anyways, we don't have to get into that. But that's how you figure out your average on things is you add them all up and divide it by the number of things. And so here, to find the length of this middle line, in our example, remember this was up here, this was 4, and this was 7. So we have two things, and we're trying to find the average of something. And so if I wanted to find out the middle length here, you go, okay, well that EF should be 4 plus 7 divided by 2, like we had in that problem above. So 4 plus 7 is 11 divided by 2. And if you type that in your calculator, or just use your brain, you'd get 5.5. Cool, and that's what we had before. So it's like finding the middle of it. You're trying to find what is, you know, in between 4 and 7, or in between 5 and 12, or whatever it would be. You add those two numbers together and divide by 2. Yeah, what brain, amen. Okay, so anyways, with these here, it's a little hard to actually, you know, do this because it's on paper, but you can actually use the ruler in these situations. It's kind of cool. You can count like ticks and stuff like that to find the halfway point. So I see that there is, you know, looking here, right? I see one big tick, 2 big ticks, 3 big ticks, and then 4 big ticks out there at the end. So it'd be at 2.5 is where we actually want to go. So there would be your center point, right? And you could measure like that and then connect across. So you can actually use these rulers in a way. It's not great, but you could connect them. Wow, I despise this ruler right now. Just pretend that works. And then, you know, you'd get the halfway point here and here. And I don't have to go through all these with you guys, but we could do that, right? So this kid wants to make a wind chime, so you'd get your halfway point, right? You'd look at the halfway point of this, you'd look at the halfway point of this. We're running out of time here, so I can't do it all with you, but it'd be that idea right there where you'd connect and connect. And that's using your medians, right? And so there's your center. My whole ruler is not my friend. This computer is not my friend today at all. You do that. And then here you do your bimedians, right? So you'd find the midpoint here and connect them. And then the midpoint here and connect them. And that's where your center would be. And that's where you'd punch the hole to get the weight. Okay. So what we're just going to do at this stage is it says, not with that attitude. Anyways, yeah, we're gonna connect and figure out. It says show that the bimedian connecting the two non-parallel sides of the following trapezoids is parallel to the sides. Length is the median of the parallel side length, so it'd be half of them. So what we're gonna do is first we're gonna look at finding the two midpoints, okay, along the non-parallel sides. So here I go, I'm looking here to here. I see this goes up 1 over 4, up 1 over 4. So it does that twice. So right in there would be our midpoint. Much easier when there's grids. And then down here, right, it goes up 3 over 1, up 3 over 1. So right in the middle of that, right where my mouse is there, that's your midpoint as well. And so if I do connect that with a ruler, I'm going to go crazy today, man. I tell you. This is not my day. These laptops today. All right, so my goodness, we need to figure out that all three of these lines are parallel. So in order to do that, parallel means same slope. So if we zoom in, we should look at the slope of all three of these sides. So I'm going to start here and look for the next nice point. So I look down, I go, no, 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 right there. So to get there, what is my slope? Well, remember, rise over run. So this looks like it goes down 2 over 1, 2, 3. So down 2 over 3. Your slope of this one is rise over run. Down 2 over 3. Let's see, next one. Over here. We go down 2, looking for the next nice point, right? Next nice point is where, right there. Perfect, right? Looks to be the exact same. So our slope is down 2 over 3. Nice negative, exactly same. Good. All right, so this next freaking slope. We're finding slope, Sam, to prove that this is first a trapezoid. So that's what it says. We are connecting the two non-parallel sides, right, of the following trapezoid. Show that the bimedian, so show that this bimedian connecting the two non-parallel sides, so connecting these two suckers here, the following trapezoid is parallel to the parallel side. So first we prove that they're parallel. We first prove that they have the same slope. But then we're going to look and show that this is also parallel to these two right here. So slope means parallel. So first we are showing that is parallel to the parallel sides. So that's part 1. That's what we're doing right now. And then we're going to look at the length and finding that it is the median of the two. So it's halfway between the two other lengths. And that'll be the challenging aspect here. So again, I'm going to start here. I'm going to look for the next nice point. No, no, no. Hey, there it is, right? So yes, they are all the same. You go down to over 3. So all 3 lines have same slope. Okay, so now what we need to do is we need to figure out their length. And actually what we would love to be able to do to be accurate here is use the Pythagorean Theorem, which a few of you guys seemed like you knew, but I can't assume that everyone knows the Pythagorean Theorem. And then we could use that to figure out those lines' exact values. So if you're interested in that, you want to show off your skills, for sure, you could try that. But what we're going to do is we're actually just going to go and use our ruler here. Oh, yeah. I can't use my ruler. It is useless. Oh, okay. I can use it when we're turning it for some reason. So what I would do is I would just count ticks here, okay, to figure out how many you got. Now, just so we're clear, if you look at the big ticks in here, like these ones, and if you count, it's 1, 2, 3, 4, 5 to here, and then 10 to here. So this is from 0 to 10. And here's another 10, so it'd be 20. And then here would be 25, 26, 27. Okay, we'll call it 27. So in here, this is 27. Yeah. $27. Oh my gosh. Okay, so this one here, this would be 10, 20, 30, 35, 36. 36 ticks. 27 ticks. And then this last one. Remind me to restart my computer after this class. Would be 10, 15, 16, 17, 18 ticks. So I want to prove that 36 and 18, like halfway between them, is around 27. Now we didn't do it exactly, right? So it should be just pretty close, within, a couple ticks. So if I wanted to do that, if I want to figure out what the middle one is, I'm just going to take our 36 plus our 18 and divide it by 2. Okay, so 36 plus 18, it's going to be, 46 plus 8, and then you're going to have 54. So 54 divided by 2. And if you do 54 divided by 2, well, if you just did 50 divided by 2, it'd be 25. And then if you take that 4 and divide that by 2, yeah, 27. 27, perfect. So 27. Surprised at how well that worked out based on us, you guys can't see my screen there because my face is in the way. So it's good. So therefore, the bimedian is the average of the lengths. The average of the lengths. Okay, well, that was top 10 most frustrating, did not work, could not click lessons of the week, and it's only Monday. It's just how she goes. All right, well, there's only 9 minutes left, so I've just got 2 questions at the top there for you, 414, number 5 and 7. So if you could just try those 2 for me, that would make me happy. We'll take those suckers up this morning. Yeah, anyways, sorry that didn't work out. That was a little frustrating, but all good. We'll push on tomorrow. We'll try some of those angle laws will solve some cool problems. It'll be a lot smoother tomorrow, we're hoping. So anyways, guys, thanks again for watching. If you got any questions, hit me up on Teams. It'll probably end the stream there, so that way the rewatch is a little bit shorter. But other than that, you guys have a great day. And thinking about you guys, and hope everything was good. You had a good weekend, and this math lesson wasn't too frustrating for you. You can keep rocking and rolling throughout the rest of your day. Those of you that are Bible, rocking and rolling. Thanks, Zion. I needed that. I needed that forgiveness. I'm sorry that this was a gong show, but I appreciate that. See you, Jared. See you, Kendra. Have a good day, guys.